So we're starting 4.4 logarithmic and exponential equations. Let's start. So today we will use the properties of log or the laws of logarithm also. Share the desktop. Journal. Sign up. Okay. All right. So 4.4 is exponential and log equation. So 4.4 is exponential and log equation. I think I might have to wear my reading glasses soon. Okay. Now, exponential equation. They're not as clear as before, or maybe the glare. So, exponential equation. All right. Okay, what is an exponential equation? So, an exponential equation has variable which occurs in the exponent. So your variable is on the exponent. Yeah. For example, of an exponential equation is 5 raised to the x plus 2 is equal to 9. And our variable is on the exponent. So this is an exponential equation. All right. Now, the next one, what about if I have something like this? X cubed plus 5x squared minus 3x equals 0. Is this an exponential equation? Is it? No, why not? Yeah, the variable's not on the exponent. So what do we call this? Polynomial equation. That's right. Or cubic equation because it's degree 3. You're right. This is not an exponential equation. So not exponential. Right? Okay. So how would you actually solve an exponential equation? So to solve an exponential equation, so what we do is isolate the exponents expression on one side, right? Okay, now take logs from both sides. So we have to bring the exponents down. How? By taking logs from both sides, or applying logs from both sides, to both sides. So the goal is to bring the exponent down. Yeah. So the goal is to bring down the exponent, because that's what you want to solve. All right, and then we solve. Okay. Are we ready for so we're going to solve the first one. 5 raised to the x plus 2 is equal to 9. So we're going to solve that. Are you ready? The next page. Okay, so solve. Number 1. 5 raised to the x plus 2 is equal to 9. And then number 2, we have something like 2 to the 3x plus 1 is equal to 3 raised to the 2x minus 3. All right. Are we ready? Okay. Now, first of all, can we write 5 and 9 using the same base? No. So, if, for example, these were, instead of 9, these were 25, what would you do? So this is equal to 5 squared, isn't it? So then you will have x plus 2 is equal to 2, so x is equal to 0, yes. But it wasn't, so I'm going to write it again. So 5 raised to the x plus 2 is equal to 9. Maybe I should change this to be number 2. Yeah. So this is number 3. Sorry. So I just want to show you the difference when you could write the base. And you can write the base using the same base, and then this one you can't. So what you want to do is apply logs to both sides. Now some books use log base 10. I prefer to use ln, so I'm going to put ln. But you could use log. So instead of ln, you could use log. Yeah, log base 10. So now, what am I supposed to do after I apply ln to both sides? Are we able to bring down the log? The exponent, I'm sorry, yes. So x plus 2 times ln 5 is equal to ln 9. All right. So then what do we do? Yes, so x ln 5 plus 2 ln 5 is equals to ln 9. All right. So we distribute. Let me make sure my phone is silent. Oh, yeah, it's silent. So now what should we do to solve for x? We isolate expressions containing x. So what is it? X ln 5 is equal to ln 9 minus 2 ln 5. Okay? Good. What next? How do I solve for x? Divide both sides by ln 5. Yes. All right. So this is your exact answer, ln 9 minus 2 ln 5 divided by ln 5. Now, can we get an approximate value? So this is your exact answer. But we need an approximate answer. What is actually ln 9 minus 2 ln 5 divided by ln 5? Can we try to use the calculator? Yes, this one is calculator. All right. So what is this? ln 9. So if you are going to write them all on one shot, you should put parentheses here. ln 9 minus 2 ln 5. So parentheses ln 9.
How many decimals?
3 decimals approximately. Minus 2 ln 5 divided by ln 5. All right. So what's the answer? Yes. Good. So this is called approximate answer. Doable? Okay. Do you think you could try number 3? Okay. And then let me give you a few more. And I will give you back your exam. No, not your exam. Your extra credit and your quizzes. Are we supposed to have quiz today? Yeah or no? Did I say we were going to have a quiz? No? No? Okay. Should I trust you? So I didn't say anything about the quiz? Okay, so we'll have a quiz on Wednesday. Okay. So next Monday I will not be here. And then the week of November 7th, I will not be here, but you will have Dr. Kazimir. He's my department chair. We will talk. Oh my gosh, too much reading. So that's why I didn't finish reading it. It's too much. So I hope I could do your exam tomorrow. Okay. Too much reading. All right, would you please turn to the quiz, please? It's really hot here. Was 72 okay with you? Alright, let's see. So you have 2 quizzes and 1 extra credit, right? Okay, so Renee. So if you did everything, then you have to read it. Okay. Sophia? Jocelyn? Elizabeth? And Melissa? Elizabeth and Melissa? Brian? Never come here? Alright, Justin? Oh, by the way, the extra credit is out of 5 points. Yeah. So it's not out of 10 points for the extra credit. So it's going to be added to your test score, chapter 3. Yeah. For the extra credit. So it's 5 points max, not 10 points. Alex? Excellent. Roger? Jose Garcia? Natalie? Is Kevin here? Okay. Sandra? Yanli? Oh, one more Sandra. Did you get all of yours? Or did you get all of them? Yolanda is here? No. Yanli, you have to leave. Two. Oh, okay, that's fine. I got the lowest one. Valentine? Maria? And then Cicely? Cicely not here? I heard there's a lot of lightning on the radio. Is it true? What happened? Usually not, right? Josh is not here. Maybe because of the lightning. Well, I mean, no. Alfredo? Nicholas? Ortiz? Fernando Orozco? Diana. Like to write it, Diana? Andrew, Reyes. Jennifer Reyes. So, Sonia. Steve. Sonia, one more. Steven, one more. Mosterios is here or no? Yeah, so that's how you get your here, so you shouldn't have to leave. If you're practically here, except I have a thing called clear. Jose Sofete, and then Jeff. And then Sal. And Alex then. Okay, there is one quiz with no name. So I don't know who this belongs to. So, quiz where you have to grab two things. This quiz with no name. I don't know who this belongs to. Did anybody miss anything in the quiz? No? Then I don't know who it belongs to. Okay. Alright. Are you done with what I asked you to do? Alright, how are we going to do it? For number 3. Apply lock both sides. Okay, ln. Alright. Why do I like ln? Because sometimes we have e, so ln e is 1. Yeah, that's why I like ln rather than log base 10. Can you use log base 10? Of course. Yeah, it doesn't make a difference. You can use log base 10. Okay, so how do we bring down? So 3x plus 1 ln 2, let's see, did I miss anything here? Equals to 2x minus 3 ln 3. What am I missing? Parentheses, yes, you're right. So I have these parentheses which I need to remove. How do I remove my parentheses? Distribute, so 3x ln 2 plus ln 2, 1 ln 2 is ln 2, so we will not write it as 1 ln 2, is equals to 2x ln 3 minus 3 ln 3, right? Okay. Now, let's bring down the x's on one side. So, if we choose the left, then we will have 3x ln 2 minus 2x ln 3 is equal to what? Negative ln 2 minus 3 ln 3. So what are we doing here? Basically, we want to solve for x. So we will have x all on one side. Right? Now, what am I supposed to do now? I have two x's. What do we do now to solve for x? Factor it out, you're right. So x, factor out the x. What are we left with? 3 ln 2 minus 2 ln 3. Good. Are we okay so far? Okay. So equals to negative ln 2 minus 3 ln 3. All right. Now, how do we solve for x? Divide both sides by 3 ln 2 minus 2 ln 3. Yes, you're right. So this cancels. This is your exact answer. Negative ln 2 minus 3 ln 3 divided by 3 ln 2 minus 2 ln 3. So this is our exact. Can we get an approximate value? Okay, now you got to be careful when we calculate this. So this one right here is an exact answer. Yeah. And then the next one is negative ln2. So I'm going to, if I calculate this, I'm going to put a parenthesis here and a parenthesis here. Right? So negative ln2 minus 3 ln3, close, and then close parentheses on the top. Oh, I forgot to put parentheses in the beginning, so let me go back. Where's my insert? Okay. So negative ln2 minus 3 ln3 parentheses divided by, open parentheses, 3 ln2 minus 2 ln3. And then close parentheses. What's your answer? Approximate answer? That's right. 33.867. Yes? So this is your approximate answer. So which one do we want to use? In the exam, I would need both. In Math Excel, what about in Math Excel? Did anybody look? This is one exact or approximate? Exact? Okay, good. But we need to know how to calculate the approximate value also. Yeah? Does anybody need help with their calculator? And because some calculator, if you want to calculate ln2, some calculator needs you to press 2 and then ln. Right? So that's a little bit more difficult, but I could show you if you need. Does anybody have that type of calculator? You can use it? Everybody can use their calculator? Yeah. Okay. Good. So you can ask me after class also. Yeah. All right. So number 3. Good. What do you think we will do at number 3? Well, I need to do something so that I could isolate my exponent, the variable. Yes, you're going to cross multiply? Yes, so we're going to cross multiply. Or multiply both sides by 1 plus e to the negative x. This is the proportion. So what is this? 50 is equal to 4 times 1 plus e to the negative x. All right. So distribute 50 is equal to 4 plus 4e to the negative x. What am I supposed to do now? Isolate, yes, you're right. We will isolate the expression containing the exponents. So subtract 4 both sides. So 4e to the negative x is equal to 46. Good. Did we isolate it yet? No, we have to divide by 4. Yes. So 46 divided by 4 is it 11.5? Yes. Okay, good. So 11.5 is e to the negative x. Now what? ln both sides? Yes. So ln both sides. You're right. So ln 11.5 is equal to negative x. So we bring down the exponent times what?
1.
ln e, which is 1. That's right. Very good. So do we know what x is? Negative ln 11.5, right? So what is ln e? 1. So remember, ln e is log base e of e, which is equal to 1. Yeah. So what if x multiplied by 1, or negative x multiplied by 1 is negative x. So when I solve for x, I'm just going to divide by negative 1. All right. So x is negative ln 11.5. This is your exact. What is the approximate value? Negative 2.442. Okay, thank you. All right. Yes? Easy? Okay. 2 more, and then we're going to discuss the log equations. All right. Oh, are you guys done? Yes. So number 4. What about if you have something like this? Actually, 4, 5, 6. X squared times 2 to the x minus 2 to the x is equal to 0. So this is x squared. All right. And then number 5, e to the 2x minus e to the x minus 6 is 0. And then number 6, e to the x minus 12 over e to the x minus 1 is 0. All right. So this is a little bit more because you're going to use a different property along with what we used earlier. So what do you think we will do with number 4? Multiply, you mean multiply by x squared? Both sides? No, yes, Andrew. Right, that's what we're going to do. So we're going to factor out 2 to the x. 2 to the x times x squared minus 1 is 0. All right. Okay, then what? Then what? 2 to the x times, can we factor out x squared minus 1? X plus 1, x minus 1 is 0. Then what? 2 to the x is equal to 0, or x plus 1 is equal to 0, or x minus 1 is equal to 0. X minus 1 is equal to 0. Right? Is it possible to have 2 to the x equals to 0? Is it possible? So, well, how would you solve 2 to the x equals 0? Is it possible? Then you bring down, just say we want to do ln both sides. What is ln 0? What is ln 0? What is the domain of log? What is the domain of log? So remember the graph of log function? 0 to infinity. Does it include 0? No. So there is no solution here, right? And if you put in ln 0, what is ln 0? There's no solution. So what are your solutions? So x is equal to negative 1, or x is equal to 1. Finish. Yeah. There is no x will, there's no solution for 2 to the x is equal to 0. So let's remember the domain of log is 0 to infinity. It doesn't include 0. Yeah. All right. Yes.
I thought ln -1 was undefined.
Yes. Okay. So we're not taking ln here. So it is 2 to the x times x plus 1 times x minus 1, right?
Okay.
So, you get it?
Yeah.
Okay. So it's 2 to the x equals 0. Yeah. So each one of these are 0. So when I say x equals -1, it's from here. Yeah. Okay. Good. Now, how about number 5? What should we do here? Yeah, but I have a 6 here. I can't factor out e to the x, right? So quiet. So what we should do here is to let u equals to x. Let u equals to what? E to the x. Let u equals to e to the x. Do I have a u square? Where is my u square? E to the 2x. This is u square. Yes. So is it clear why this is u square? Because what if I have e to the x square? So e to the 2x, yeah. What is e to the x square? E to the 2x. So this is your u square, right? So we do have a u square, which is e to the 2x. So if we let u equals to e to the x, then what is this equation going to be? That's right. And then we know how to solve this, don't we? Okay. So u minus 3 times u plus 2 is 0. So u is 3 or u equals -2. Are we done? No, because I'm done with u, that's true, but I want to solve for x. Then what do we do? Substitute back, yes. So e to the x is equal to 3. Or e to the x is equal to -2. All right, now we know how to solve this, don't we? E to the x equals to 3. How do we solve this? ln both sides. Okay. So x times ln e is ln 3. All right. What is ln e again? 1. So this is 1. So ln e is 1. So you have only x is ln 3. Approximately what? 1.099? Okay. All right. Okay, then what about the other one? E to the x is equal to -2. No solution? Yes. Why not? Yes, that's right. You remember e to the x, the graph looks like this. Where is the negative? So if you remember the graph, then you can write no solution directly. Right? Or if you want to use ln, then let's see what happens here. So x ln e is equal to ln of -2. Then what happens when we evaluate ln of -2? Yeah, this is no solution. So we only have one solution. Are we good so far? Okay, can you try number 6? So what would you do with number 6? Clear the fraction. Clear the denominator. How do I clear the denominator? Multiply each one of them by? Okay. Can you try it really quick? Okay. All right. Let's see. All right, so let's multiply by e to the x. So e to the x, e to the x, e to the x, e to the x. So what do we have? E to the 2x, or e to the x squared, which is the same as e to the 2x. You're right. Minus 12 minus e to the x is equal to 0. So e to the 2x minus e to the x, you know what to do with this, don't you? What do you do? Let u equals to, okay, then what do you have? U squared minus u minus 12 is 0, yeah. And then what? U minus 4, u plus 3 is 0, so u equals 4, or u equals negative 3. So we're done with the u, but we need x. So e to the x is equal to 4, or e to the x equals to negative 3. And then ln both sides, right? X ln e is equal to ln 4. All right. So ln e is 1. So x is ln 4, which is approximately 1.386. Thank you. How about the other one? Yes. Done. Is it doable? Okay. Which ones do you have to pay attention on? The second one, right? Number 2, where you have the 2 x's on 2 sides. If I ask you this on the exam, you can do it? Hopefully, yes. Okay. All right, good. I'm done with exponential equation. Can I clarify anything before we move on? No? Are we good? Yes? Okay. So next, B is log equation. All right. So what is a log equation? So a logarithmic equation is an equation in which the variable occurs as an argument of log. So we call it argument of log. It's not like debate or something like that. It's called the argument of log. It's the expression that follows the log expression. Okay. Okay. For example, of so example, ln x is equal to 100. So this is called the argument. Okay. It follows the log expression. It follows the log, basically. So how do you solve these? So steps to solve a log equation. Okay. Simplify so that, sorry, each side of equation contains one expression. Okay, one log expression. Okay. Now there are 2 things you could do to take care of the logs. Use the cancellation property Cancellation is 2L, right? A raised to the log base A of x is equal to x, or rewrite using exponent. 3. Solve the resulting equation. To solve the resulting equation and check. Check to make sure the solution is in the domain. What is the domain of log? 0 to infinity. So the argument of log must be positive. That's true. All right. So, for example, and we also have log inequality here. Suppose, let's solve this. Solve. Ln x is 10. And then number 2, log base 2 of x squared minus x minus 2 is equal to 2. So ln x is 10, so what do we do? Do we isolate so that I only have one expression on the left? Yes. How about on the right? Do I have only one expression? Yes. So we're good, right? Now, do you want to rewrite these as exponent or use the cancellation property? So I think this is easier. Yeah. So I'm going to use this. Okay. Now, ln x, this is log with base what? E. So this is log base E of x is equal to 10. Right? Now, if I want to use the cancellation property, what base do I use? Here. E. Okay, so now E raised to the left-hand side is equal to E raised to the right-hand side. So I'm just taking the base here and then rewrite it as E raised to the left-hand side is equal to E raised to the right-hand side. So what is E raised to the log base E of x? X. Ln is log base E. Yeah. Like, if you just have log like this, what is the base? If you don't write it, it's base 10, yes. If it is ln, then the base is E. Do you remember what E is? E is the... Yes, yes, you're right. That's right. So this is E to the 10. So what is this approximately? Well, this is a big number, isn't it? So x is E to the 10. What is the approximate value? Because your calculator has E. Oof. 22,026.466. Is it? Yes. Okay. Good. Is it doable? Okay. Oh, we have to check. If I substitute 22,00266 here, is this in the domain? Is it positive? When I substitute here, is it positive? Yes. So yes, this is a solution. So make sure when we substitute x back here, it is positive. Otherwise, it's not a solution. So let's do the next one. See. All right. Now, number 2. What am I supposed to do? Do I have a one log expression on the left and one on the right? Yes. So I could cancel the log. How do I cancel the log? What is the base? 2. So 2 raised to the left is equal to 2 raised to the right. So you're taking the base now, raise it to the left expression, and that should be equal to 2 raise it to the other side. All right. Now, what is 2 raised to the log base 2 of x squared minus x minus 2? X squared minus x minus 2 is equal to 4. Yes. And then we know how to solve these, don't we? So x squared minus x minus 6 is 0. Okay. Oh, subtract 4 both sides? Yeah. So factor? X minus 3, x plus 2. So x is 3, right? Or x is equal to negative 2. Now, which one is the solution? Okay, so let's substitute back in here. So if I substitute back in here, then what do I have? 3 squared minus 3 minus 2. Is it positive? So I don't care what the value is. When I substitute here, I just need to make sure this is positive. So when I put the 3 in here, is it positive? Yes. What about here? So when I put negative 2 here, is it positive also? So let's see. It's negative 2 squared minus negative 2 minus 2. So what is this? 4 plus 4 minus 2. Is it positive? Yes, so both are solution. Why? Because when I substitute it back to the log, they're positive. Even though x is negative, but when I substitute the value in here, it is positive. Yeah. So you have 2 solutions. All right. Now, let's do 2 more. And then I think there's an inequality which I have to discuss tomorrow, not yesterday. Right. Let's see. So number 3. Ready? Okay. Number 3 and number 4. What about if we have log base 5 of x plus 1 minus log base 5 of x minus 1 is equal to 2. And then this one is ln x minus 1 plus ln x plus 2 is equal to 1. All right. I think the last one is a little bit, you have to use quadratic formulas on the last one. Okay, now, number 3. Do I have one log expression on the left? No, we have how many? 2. So can we combine it? Yes. How do we combine these? Log base 5, this is subtraction, so divide, yes. X plus 1 over x minus 1. That's right. Is equal to 2. Now, do I have one log expression on the left? Yes. How about on the right? Yes, also. So can I cancel the logs now? All right. How do we cancel the logs? Well, the base is 5. So if I take 5, raise it to the left-hand side, and 5, raise it to the right-hand side, then I will cancel the log. Oh, okay. When I raise 5 to the left-hand side, what do I have? X plus 1 over x minus 1. When I raise 5 to the right-hand side, what do I have? 25. 5 squared is 25. All right, can we solve this? Oh yeah, this is a proportion. Or you could say, oh, I'm going to multiply both sides by -1. So x plus 1 is equal to 25 times x minus 1. So x plus 1 is 25x minus 25. All right. So where do I want my x? Left or right? Right? Okay. So subtract by x, so 24x. Add by 25, so this is 26. Okay. So then it's easy. We just divide by 24 both sides. So x is 13 over 12. You could get an approximate value if you like. But you could just leave it as 13 over 12 because it's an exact fraction, right? 1.0833 or 83. Okay. Is it a solution though? So how do I check if it is a solution? Well, easy. I just put 13 over 12, so I'm looking at this. These two. 13 over 12 plus 1, is it positive or negative? 13 over 12 minus 1, positive or negative? Then this is a solution. Easy? Okay. Should we do one more? Yes? Let's finish the last one, or you want to wait till tomorrow? Finish. Okay. So we have two expressions. What do we want to do? Combine them. How do I combine these? This is a plus. Multiply? Okay. So this is ln of x squared minus x, no, plus x, right? Minus 2 equals 1. Good. Yeah, this is a little bit because you need to use the quadratic formula here. There's an e. All right, now, how do I cancel my logs? So ln is log base what? Yes. So ln is log base e. And if I want to cancel log base e, what do I do? Take the e, raise it to the left. Take the same e, raise it to the right. Okay. So this is x squared plus x minus 2 is equal to, what is e to the first power? E. All right. Well, I have a number and an e. We have to use quadratic formula, right? So standard form. Do I know what a is before I use my quadratic formula? A is 1. B is 1. What is C? Negative 2 minus E. So A is 1, B is 1, C is negative 2 minus E. This is my quadratic formula, right? X is negative B plus or minus square root of B squared minus 4AC all over 2A. Do you remember the quadratic formula? Yeah, okay. Negative B, what is negative B? Negative 1 plus or minus square root of B squared is 1 minus 4 times, oh, but this is negative number, so it's plus 4 times 2 plus e, isn't it? Or maybe let's just do it slowly so you can follow what I'm doing. So it's minus 4, a is 1. Well, I don't write the 1 times c. Minus 2 minus e. Over 2. So negative 1 plus or minus square root of 1 plus 4e divided by 2. All right. So this is my solution. Which one? Both or just one of them? So what is your x? So x is negative 1 plus square root of 1 plus 4e over 2. Or, what is the other one? X is negative 1 minus square root of 1 plus 4e. Oh, what did I do? Oh, how did I get 4e? I think I made a mistake here. What am I supposed to write here? Plus 8, yes. Plus 4e. So, yes. So, it's not 1 here. This is supposed to be 9. Yes. That's what I was. All right. 9 divided by 2. So, what is this value approximately? I think the second one is not a solution because it's negative, but let's see. Let's just get what the approximate value is. Negative 1 plus square root of, where's my square root? Square root of 9 plus 4e. Okay. Divided by 2. So it's approximately 1 point. Can you tell me what the value is? Okay. So negative 1 plus square root of 9 plus 4e. Yes, divided by 2. Did you guys get that? 1.729?
Yes.
What about the other one? Yes, thank you. So negative 1 minus square root of 9 plus 4e. Negative 2.79? Yes, you're right. 729. Okay. So which one is the solution? Yeah. The second one, so we substitute the value here and the value here. So 1.79 minus 1 is greater than 1. How about this one? This one is negative. So we only have one solution. Yes? Okay. Alrighty. I hope I could finish grading tomorrow. Yeah. There's so many things to grade this weekend. You saw my piles, right? Okay. Okay, have a good one. So Monday next week I will not be here. Yeah. So have a happy Halloween. This is the time I have fun, but yeah, this is the first time I'm absent because I want to be absent. All right. Yes, Alex. Everybody okay? Let me stop the recording. Yes. So I will see you tomorrow and finish this up. Yes? All right. So we're done with logarithmic and exponential equations. Tomorrow we will still do more examples, but we're practically done.